Alright, welcome to this video. We are going to be looking at the calculation aspect for number-based systems. The last video we looked at numeration, and we saw that we have different kinds of numeration, like base 10, the Denary system. We saw binary, we saw octal, we saw duodecimal and hexadecimal. So today we are going to be converting numbers between bases. Converting numbers between bases. So what does that mean? If you have a number in base 10, for instance, how do we convert it to base 2? Basic conversion skills. And if you have, that's not just base 2, other bases, base 8, for instance, that's octal, base 12, and so on. It could be base 7, it could be base 5. So converting from base 10 to other bases, I will just say, number 1, converting from base 10 that we know to other bases that we might not be so familiar with. Why? Because we are not used to it. So the rule for converting from base 10 to other bases is to do a continuous division. Divide that number, that base 10 number, by the destination base number continuously until you get to 0. How do I mean? Example, if we are told to convert 25 base 10, mind you, when you are writing notations for number bases, you put as a subscript is just a small number at the bottom of the reference number. You put it to denote what number based system you are in. You know, we don't go ahead putting 10, 10, 10. It's not 10 in all the numbers, because we know that all numbers that we deal with is in base 10. For instance, if you want to write how much you have in your account, your plenty money, you write 5 million. Let me go to that one. 5M. Don't go about putting base 10, because all of us know that it's decimal. So that is just by the wayside. But if in mathematical discussions and expression you want to denote numbers, you put the subscript denoting the number. So if they say convert 25 base 10, that's what this one means, to base 2. So what we are dealing with now is converting from base 10 to other bases. Like I said, you do a continuous division of 25 by 2. This base 2 you are going to. You do it by continuous division until you get to 0. Then you now aggregate the remainders. How does that work? The first thing I do, I just rule on my line like this. Rule my line. I write 25 here. This is where we are. This is where we are, 25, and it's in base 10. They say we should convert to what? Base 2. So we are going to bring this base 2 we are converting to and put it as the divisor outside. And continuously dividing 25 by 2. You write the division, the what you divided, what you got, and remainder whatever. So I'm here. So 25 divided by 2. Now I will be saying 25 into 2 into 25. It is the same thing as saying 25 divided by 2. So 2 into 25, 2 into this 25 is 1, that's 2 into 2 is 1, and 2 into 5 is 2. Because 2 times 12 is 24, but it's remaining 1, so remainder 1. So this is correct, like this. 2 into 25 is 12 remainder 1. Then I still go again and do division, because I'm not getting to 0. Because I said do continuous division by 2 until you get to 0. So I say 2 again can go into 12. How many times? 6 times. No remainder, remainder 0. Then here again, 2 into 6 is 3 times, remainder 0, no remainder. Now again, 2 into 3 is 1 time, only 1. It goes into 3 1 times. So, but 1 remainder 1. Because this one is not going to 0 yet, I still divide by 2. So 2 into 1, or 1 divided by 2. 2 into 1 is 0. You cannot go 0, but remainder 1. At this point, I'm going to aggregate my answers, all the remainders, from bottom to top. See where my arrow is going to. I'm going to aggregate them. I'm going to bring them together. That's take them one by one. So from here, I have first one. It forms my first digit here, 1. Okay, let me go up a little bit. So the answer is, I take this first one, 1. Then I take the second one, 1. I take this one, 0. I take this 0, 0. And I take the last one, 1. So this is in base 2. So this one is 25. That is the way 25 is in base 10. That's how this one is in base 2. They're the same thing. I just converted. So that's how to convert from base 10 to other bases. That's the first one that we are doing. If, for instance, again, we need to convert, another example, example 2. Say convert 403, which is in 10. This is another way of writing it. Instead of writing subscript 10 figure, I can write 10 in letters. So convert this one to base 3. So remember I said converting from base 10 to other bases is continuous division until you get to 0, then aggregate the remainders. So how do we go from here? I rule my line. Solution, I rule my line. First thing, just rule line first. Rule line first. Then you write your 403. This is base 10. Now I'm going to convert to base 3. So I put my 3 at the side here. I start my division. So 3 into 4 is 1. There's 1. Remember 1. That is 1 remaining here. Carry the 1 to this place. It becomes 10. You are shifting it. It becomes 10. So 3 into 10 is 3 times. 3 times. Remember 1 again. That one, put it here. 3 into 13 is how many times? 4 times. 4. That's 12. Remainder 1. This is correct. Why? Because if I say 3 times 4 is 12, that is 2. Let me just do the sum. 3 times 4 is 12, that's 2. Carry 1. 3 times 3 is 9, plus that one is 10. Then carry 1. 3 times 1 is 3, plus the one that you carry, that's 4. So this is 402, remember 1. Add the 1, I'm back to this one. So this is, just do your division until you get to 0. So the next thing again, I go 3 into 13. 13, these first 2 digits. 3 into 13 is 4. That is 12 that is going into actually. But remember 1. That one, put it in front of this 4. It now becomes 14. 3 into 14 is 4 again, remember 2. So I add 4 here, remember 2. You can check again the way I check for that first one. Check 3 times this one plus this one must give you this. 3 times 44. Whatever you get in the multiplication times 2 plus 2 will give you 1. That's how you check. So I go again. 3 into 4 in here is 1. Then the remainder 1 here. Put the 1 in front of this 14. This 4 will become 14. 3 into 14 is how many times? 4 times again. 4 remainder 2. Okay. Again, 3 into 14 is again 4 because it's 12 we are going into now. 3 into 14 is 4, remainder 2. 3 into 4 is 1, remainder 1. How? Because 3 times 1 is 3, plus this remainder give you 4. So I'm correct. So because it's not 0 yet, I can still put 1 more 3 again. 3 into 1 is 0, remainder 1. So you have gotten your base 3. Just start from the bottom to top, and call out the numbers one by one, and repeat them. 1, 1, 2, 2, to 1 in base 3. Notice how when you are representing number bases, you don't see any number in any digit here greater than your base. If you see it's error. So if you look at it now, inspect every digit here. 1, 2, inspect them. None of them is greater than 3. It must be lower than 3. So what you can have under base 3 is either 0, 1, and 2. We said it in the previous video. You go to the previous video and check how we talked about the number bases. So even if it's base 4, you must not see any 4 and above in your computation or in your expressions. So this is converting from other bases to base 10. See base 2 here. Sorry, base 1. I'm sorry, it's base 2. Actually, base 2. This is base 2. I will not see any number greater than or equal to 2. For base 3, I will not see any number equal to 3 or greater than 3. And so on. That's how you know that you are correct. So we have done converting from base 10 to other bases. Now how about converting to other bases to base 10? So we're going to look at that in a short while. Converting to other bases to base 10. So let me take this off quickly. Okay, so we're going to convert from other bases to base 10 or to decimal. Please note the terms. You can use any terms in your exam. They can tell you base 10, they can tell you denary, they can tell you decimal. It's the same thing. If they come and say octal, octal is base 8. Check my previous video for numeration. You will see that derivation there. So convert from other bases to base 10. What do? You will do a continuous multiplication of each of the terms or digits in that base by the base you are currently on. Let me explain, or use an example to explain. If, for instance, we are told to convert, let me give you an example. If you are told to convert, put the question on the board, convert 11102 11101, then I can put 2 like this. So this is binary. To decimal, see how they put it. Decimal. So how do you do that? You look at what you are given like this. So you are going to multiply each of this number digit here by 2. Multiply it by 2 and add. When you are doing that, this 2, which is the base, will be raised to a power of the tenth that is represented here. Let me explain again. Okay, see, solution. The first thing you do is to bring out these digits, these numbers here. 1, this is the first one, this is the second one, this is the third one, then you have a 0 and you have a 1. Now the position of this one here in the power of 10, this one is actually 10 raised to the power 0. So the power of 10 here is 0. The power of 10 here is 1. The power of 10 here is 2. The power of 10 here is 3. The power of 10 here is 4. So that's how it is. If you have another one here, the power of 10 there will be 5, and so on, it will be increasing. So from the left to the right, from the right to the left, the 0 will be counting from 0, 1, 2, 3, 4, and so on. So if you have this like this, you will bring every term out. So I want to start solving. This is the first one. I'll write 1 here. I'll say times 2. This 2 is the base, times 2. But this base will raise to the power of the tenth. The position, the tenth. The tenth there is in 10,000. So it's raised to the power 4, this 4 here. Then I'll close my bracket. I'll now say plus, then I'll take this other one again, open bracket, 1 times the 2 is the base. You understand? Raised to the power of 3, the position of the tenth there is a 10,000. Sorry, it's 1,000. Sorry, this is 10,000, it's 1,000. Okay? Then plus 1 times 2 raised to the power 2. Then plus, I've done 1, 2, 3. That's 1, 2, 3. And this one is plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. This is what you will get. This is what you are doing. You're going to just express all these ones. Express them. You see how it goes. So for converting order base to base 10, the first thing you do is to take each of the individual digits, multiply them, each of them by the base. If it was 3 here, that you have base 3, convert to decimal, what you will multiply by each of the 10 is 3 here. But the powers here depends on the position of the 10. You can just write it out like this and start from the last one and put 0 here. 1, 2, 3, 4. See, it's increasing. It's increasing. If you don't want to start memorizing or knowing how the positions are, just expand. Do your expansion. 1 times your base, you close the bracket, plus the second digit times your base, plus third digit times your base, plus 4 digits times your base, and plus 6 digits times your base. You close all the brackets. Pair them in twos. Then what you do again is to start from the last one here, where the base is, put 0 there. Then you have 1, 2, 3, 4, and so on until the 10 ends. So you now do the expression. The power of, you start from this first one, this first 10 here. 2 raised to the power 4 is 16, plus times 1 is still 16. Write 16 here. Plus, this is the plus. Then this one is 3 raised to the power 2 is 8. 8 times 1, 8. Plus 2 raised to the power of 2 is 4. 2 raised to the power of 2 is 4. 2 raised to the power of 2 is 4. 4 times 1 is 4. Plus 2 raised to the power of 1 is 2. But 2 times 0 is 0. Plus 2 raised to the power of 0 is 1. And 1 times 1 is 1. So the answer is 16 plus 8 plus 4 plus 0 plus 1. So I have it here as 16 plus 8 is 24. 24 plus 4 is 28. 28 plus 1 is 29. That's the answer. So this is in base 10. So you have converted this string of numbers to base 10. So actually this one answer are the same thing. Just that this one is in one form, is in base 2. And this one is in base 10. The same thing. Just that in the same magnitude, in the same magnitude you are representing. You are representing the same number, just that in different form. Okay. We will do further examples and we'll wrap up. I think I have one other one to give us, to share with us. Let's convert from order base to base 10. Let's convert, okay, let me give us this one. Order base to base 10. Let's convert this one. Convert 1, 1, 1, sorry, 1, 1, 1, 1, 0, 0 to this in base 2 to base 10. Okay, like this one I said continuous multiplication of each of the terms by the base on and use the raise the base to the power of the tenth in that place, the power of the tenth in that place. Yes. So this is it. So I have the first one here. Like I said, solution. Just bring out this first one. Say 1 times is 2. okay, plus 1 times another 2 plus 1 times the third 2 plus the fourth one, 1 times 2 again, plus 0 times 2 plus 0 times 2. Okay, I probably did the addition that I can just put the powers after I've written them out. So not to waste your time, start from the last term here by your right. Start from the last term. Put your power here. That's 0. It increases by 1, 2, 3, 4, and 5. Okay. So you compute. So this one now is 22 raised to power 5 is 32. 32 times 1 is 32. Plus 3 raised to power 4 is 16. 16 plus 1, 16 times 1 is 16. Plus 3 raised to power 3 is 8. 8 times 1 is 8. Plus 3 raised to power of 2 is 4, is 2. 4 times 1 is 4. And this one is 0 because 2 raised to the power of 1 is 2. 2 times 0 is 0. And plus 2 raised to the power of 0 is 1. 1 times 0 is 0 again. So we're going to add all this up. So I'm doing this addition. 32 plus 8 is already 40. 40 plus 16 is 56. And 6 plus 4 is 60. Okay. 60. So this is in 10. Okay, let's go by it again. 32 plus 8 is 40. Yes. 40 plus 16 is 56. 56 plus 4 is 60. So this is base 10. So the same thing, if you are giving other one, not only in base 2, if for instance this was in base 3, if this one was in base 3 for instance, what you should be having here is 3. That is, you are multiplying each of the 10 by the base. You understand? Each of the 10 by the base. So if it's 3 that you have here, each 10, each digit here by the base, raised to the power of the tenth, the power of the tenth of that particular position. Alright, so we're going to draw the close of this video. I hope it has been informative for you, and I'd like to thank you for viewing.